Hey guys, this is 6.6, our last lesson. Congratulations. You're about to finish college algebra. Well done. Okay, we are using the rules for expanding and condensing logarithmic expressions that we learned in the last class to solve complicated logarithmic and exponential equations today. So we're going to use these, remember from last class, to just solve 6 examples. Not plug it in. Okay. So the first one is 4. I'm going to write them down here just to have a little bit more space. So I'm just going to call this number 1. It's 4 times the log base 6 of x equals log base 6 of 16. Okay, so I know this has plus or minus or a power, but it doesn't have any equal signs, right? So how can I help? What rule of these can I use to solve this if it has an equal sign instead of a plus or a minus? Well, I can use algebra to move this over here, and then I will have a minus sign, right? So I'm just going to subtract this from either side. Now I have 4 log base 6 of x minus log base 6 of 16 equals 0. Good. Okay. Now, because it has a minus sign, I can condense it to a single log with a division bar between the 2 logs. So, wait, first, right? First, I can move this 4 back up here. So I'm going to rewrite that as the log base 6 of x to the 4th minus the log base 6 of 16 equals 0. All right, now I can change it to 1 division problem. Log base 6 of x to the 4th divided by 16. Good, equals 0. Now I'm going to use I'm going to convert from the log form to the exponential form, and I'm going to be able to solve it for x. Because if from here, I cannot put x into my calculator, right? And get an answer, but I want to solve for x. So I'm going to reconvert it into exponent form. So to do that, I start with the base. There's log base 6, so I start with the base, and I make a circle, right? Is 6 to the power of 0 equals x to the 4th over 16. And I just use the rule that says how to convert from the logarithmic form to the exponential form. Okay. So now I have 6 to the 0 power is x to the 4th over 16. Anything to the 0 power is 1, right? 6 to the power of 0 is 1. So that becomes 1 is x to the 4th over 16. I'm going to take that 16 and multiply both sides by it. I'm going to get 16 equals x to the 4th. Yeah. Now to get rid of that 4th, I'm going to take the 4th root. Right? And when I take a root, I have to add, say, plus or minus, right? So that just becomes x because the 4th root and the 4th power cancel each other out. The 4th root of 16, oops, I'll put a 4 in. The fourth root of 16 is 2 because 2 to the fourth is 16. Can't see that. So we're going to say it's 2, and we said it's plus or minus 2, right? Now, let's check our answers. We're putting x in for the log. If you remember, we can't take the log of a negative number, so we can eliminate the -2 as one of the answers. All right, so, but I'll just do it anyway. 4 times the log base 6 of -2 is a non-real answer. But I'll check that other one. 4 times the power of log base 6 of 2 is that. And then is that the same as log, log base 6 of 16? Yes. And that makes sense because remember, we can always move that 4 up here. So 2 to the 4th power is 16. So that makes sense. So x is 2 for the first one. Let's look at the next one. Here I have log base 20 x plus 9 plus log base 20 x plus 1 is 1. Good? Okay. I know I can condense this to multiplication because the bases are the same. They're both log base 20. Good? So I can rewrite that as the log base 20 of x plus 9 times x plus 1 equals 1. Good? I'm just going to use FOIL to turn this into one quadratic expression. So now it's log 20, x times x is x squared, plus x, plus 9x, plus 9 equals 1. I'm going to simplify that to log base 20 of x squared plus 10x plus 9 equals 1. Okay. Now that it's a single log, I can convert it to exponential form, right? So just like I did here, we start with the base and go in a circle. So now I have 20 to the power of 1 is x squared plus 10x plus 9, okay? 20 to the first power is just 20, right? So that'll just say 20 is x squared plus 10x plus 9. Now I know I just have a quadratic equation, right? If I move that 20 over, set it equal to 0, I can use factoring, or if I don't see a factor, I can use the quadratic equation, quadratic formula to find my answers. So let's move that 20 over. And what I get is x squared plus 10x minus 11 equals 0. I just, instead of the 0 over here, I'm putting a 0 over here. And do you see that it is or is not factorable? What would you say? X squared becomes x and x, a negative 11. There are only two factors of 11, right? 11 and 1. But it's a negative, so one needs to be a positive and one needs to be a negative, and they need to equal a positive 10. So I'm going to say it's a positive 11 and a negative 1. Now I set them both equal to 0, and I say x is negative 11 and x is 1, right? We'll check them in our original in our original equation. So we have a negative 11. Log base 20 of, log base 20 of negative 11 plus 9 plus log base 20 of negative 11 plus 1 is a non-real answer. So we're going to say that is not possible. And we're going to go back and do it with 1. So instead of the negative 11, I'm just going to say 1. Instead of the negative 11, I'm just going to say 1. And we get 1. So this is a good answer. Oops, couldn't see what I was doing. X is 1. Here we said X is negative 2 and X is 2, but we checked it. We said that one is not true and this one is true. Good. So here we're going to say X is 1. All right, number 3. I have some natural laws. The natural log of X plus the natural log of X minus 1 is the natural log of X plus 15. Good. I know if I look at my rules here, they are being added here, but they have to have the same base. Does this have the same base? Yes, because the natural log of X is the same as log base E of X. So they both have the log base E. So I can multiply these two together. It will now look like the natural log of X times X minus 1 equals the natural log of X plus 15. Good. Now I can distribute this X through here. That becomes the natural log of X squared minus X. Good. Equals the natural log of X plus 15. Rather than one log on either side of an equal sign, I want to continue using these. So I need a plus or a minus, right? So again, I'm just going to manipulate them using algebra. So what I'm going to do is I'm going to subtract this from both sides. And what I will get is the natural log of X squared minus X minus the natural log of X plus 15 equals 0. Good. Now I can change the subtraction to a division problem. The natural log of X squared minus X over X plus 15 equals 0. Good. Now, just like we've been doing before, it is time to convert. Because ln, the natural log, is log base e, I'm going to rewrite it as log base e of X squared minus X over X plus 15 equals 0. And we're going to convert. So now I have e to the 0 power is equal to X squared minus X over X plus 15. Good? Okay. Hold on, I need to plug in my computer. Okay. Now I'm just doing algebra, right? And this is a fraction. I don't love fractions, so I'm going to multiply both sides by the denominator to get rid of the fraction. X plus 15. We know that any number to the 0 power is 1. So that's just a 1. So I'll rewrite that as x plus 15 times 1 equals x squared minus x over x plus 15 times x plus 15. So just so we're clear, that is a 1. These two cancel each other out. We are left with x plus 15 equals x squared minus x. Good? Okay. This is, again, a quadratic equation, so I'm going to set it equal to 0 by moving things over. Okay? I like my leading term, which would be the squared, to be positive, so I'm going to subtract x and subtract 15. That means over here I have 0. Here I have x squared minus 2x minus 15. Good? Just like last time, can you see factors? X times x is x squared. The negative 15, I can change to a, what are the factors of 15? 15 can be 3 and 5 or 1 and 15, right? Which one of those would add to a negative 2? If I had a negative 5 and a positive 3, I could get a negative 2, right? Minus 5 plus 3. Good. So x minus 5 equals 0. So that means x is positive 5. Here, x is negative 3. Yeah? Check your answer. Negative 3. The natural log of negative 3 plus the natural log of negative 3 minus 1 equals a non-real answer. So we'll do it with 5. The natural log of 5 plus the natural log of 5 minus 1. And then on the other side, we have the natural log of 5 plus 15. Yes, those work out. All right. So that checked out. This is not a possible answer, but this was an answer. So we're going to say here, x is 5. All right, for these last 3 examples, we have x in the exponent, the variables in the exponent, so we need to convert them to a logarithmic expression in order to solve them, okay? So we remember we start with the base and we go in a circle. So here we have log base 3 of 7 equals x. Good. Now you just put that into your calculator. And you can either say log of 7 divided by log of 3, or you can say log base 3 of 7. Either way, you get 1.77. Good. All right. Here we have 5 times 4 to the x power equals 3. Before I have something like this, I need to get rid of that 5, right? So I can divide both sides by 5. That will cancel this out. So now I have 4 to the power of x equals 3/5. And I'm going to put it into logarithmic form. So we start with the base and go in a circle. So now I have log base 4 of 3/5 equals x. Good. Log base 4 of 3/5 or log of 3/5 divided by log 4. Our answer is x equals -0.368. Good. Okay. This one looks difficult. So I cannot, right? Because I have x's in the exponents on both sides. So what can I do? What rule can I use? Here are my rules, remember? The only rule that looks helpful right now is this one, right? If this was a log, I could take the exponent and put it in front of the log. So, and whatever I do to both sides cancels itself out, right? So I could take the log of both sides so that I can move these exponents out front, okay? It sounds crazy, but I think you'll understand by the end. So I have, and I'll just move it down here, 7x to the power of x minus 3 equals 2 to the power of 2x plus 1. And I'm going to take a log. It can be the log of anything. We tend to use the natural log, so I'm just going to take the natural log of 7 to the power of x minus 3 equals the natural log of 2 to the power of 2x plus 1. It's just like multiplying both sides by 5. You don't change the answer, right? If I say 2 equals 1 plus 1, and I multiply both sides by 3, I'm not changing it, right? 3 times 2 is 6. 3 times 1 is 3. 3 times 1 is 3. I didn't change it, right? I didn't change its value. I just made it so that it's easier to work with by doing one thing to both sides. So now if I use this rule, that means I can take the r and move it down in front. So I'm going to take this x minus 3 and move it down in front. Take the 2x plus 1, move it down in front. So now what it looks like is x minus 3 times the natural log of 7 equals 2x plus 1 times the natural log of 2. Good. Let's distribute that out. So now I have x times the natural log of 7 minus 3 times the natural log of 7 equals 2x times the natural log of 2 plus the natural log of 2. Okay? And I'm solving for x. The thing I'm solving for is x. What I just did in that step was to distribute. That one's here. That one's here. That one's here. That one's here. So I just distributed, and this is one term. Okay? So now I want all my x's on one side. So I'm going to subtract 2x natural log 2 from both sides. And I'm going to move this one over here. So I'm going to add 3 natural log 7 to both sides. Okay, so now I have x natural log 7 plus 3, minus 2x natural log 2 equals 3 natural log 7 plus natural log 2. So all my x's are now on this side, and this side has no x's. Okay. All right. Now I'm going to factor out my x. So I'm going to say x natural log 7 minus 2 natural log 2 equals, I didn't do anything to this side, so I'm just rewriting it. okay? And now to get x alone, I'm going to divide both sides by this. Good. So x equals, this cancels, 3 natural log of 7 plus the natural log of 2 over the natural log of 7 minus 2 natural log of 2. And now all you're going to do is put all of that into your calculator. Ready? 3 natural log 7. Ooh, I need some parentheses. 3 natural log 7 plus natural log of 2 divided by natural log of 7 minus 2, minus 2 natural log of 2. And I get 11.67. Hold on. Oops. All right. I only have 2 plugins, and so I tried to unplug the document camera and plug in the camera, but it just turned the camera off. You guys did it. Thank you so much. You made it through college algebra. It's been a pleasure teaching you, and excellent work. And I wish you luck on your next math class. Bye.